Welcome! This is Algebra 2, Unit 3.6. How do we multiply polynomials? You guys have been doing this with binomials. We've been playing around with this on the boards a lot. You do either box method or FOIL method. The only thing that we're going to do today is we're going to step into something that's bigger than a binomial. Binomial, how I'm getting that name is, it's two terms. That means binomial. Trinomial would mean three terms. So let's look at some of these. Here is a binomial times a trinomial. I do it the same way. In fact, I'm a little bit lazy. I draw the box right underneath the trinomial so I can just drop the terms as I'm multiplying and I write the binomial over here. So remember, anytime you have x to the first power, it won't show that exponent. And remember, when you multiply, you do add the exponents. So this would be 2x to the fourth, negative x cubed, and so on. The interesting thing is, if you have like terms in the box method, those like terms will be diagonal. So as you bring the answer off, this would be 2x to the fourth. This would be a negative 6x cubed and a negative 1x cubed. Do not add their exponents. You're no longer multiplying. So a negative 6 and a negative 1, their signs are the same, so you add them together. Negative 7x cubed. Now on the next diagonal, you notice they aren't like terms, so don't combine them. We have a plus 3x squared, a plus 5x, and then a minus 15. So that's how you can do it using box method. Now, if you didn't want box method and you've done FOIL all the time, I kind of call this a clamshell. What you've got to make sure of is that this term multiplies by each of these. And as I multiply it, I draw a line. So x times x cubed, x times 2x cubed is 2x to the fourth. X times negative x squared is negative x cubed. X times 5 is 5x. Now notice how we don't have an x squared in that. We've skipped. So I want to make sure and skip a space over the 5x. Then on the minus 3 times 2x cubed would be a negative 6x cubed. So I line it up right underneath my other x cubed value. Then I have negative 3 times negative x squared. That would be a positive 3x squared. Negative 3 times 5 is negative 15. Then I would go ahead and add the like terms. So I get 2x to the fourth minus x. Whoa, wow. These are both the same sign, so I add them together. A 1 and a 6, that would be a negative 7x cubed. A plus 3x squared. A plus 5x. And then minus 15. So you notice we get the same answer as the other method. I do want you familiar with both because you may be working with people that use one method and you use the other. You still need to be able to edit their work and help them find mistakes when they need that help. Okay, special products. Hopefully when you see this kind of a special product, you notice identical, different signs. This is a conjugate. If you can remember that, then you know the outside inside wipes out, and all you really need to do is multiply your first 16x to the fourth and your last 25, I believe. Okay, so that would be a negative. Okay, because positive times negative is negative. So this is called a difference of two squares. Anytime you see a difference of two squares, where it's a perfect square number minus a perfect square number, you know you should factor them right into conjugates. Take the square root of this one, square root of that one, and put them into conjugates. You'll be practicing that in factoring. Okay, there are special products here. And if you can remember the pattern, it's really easy to not have to do the box or the FOIL. The pattern looks like this. This is a plus b squared. So I wipe out that. And I just memorize this pattern. It should make sense. This would be a squared plus, I'm going to have a BA and an AB. I can do commutative property. That's two ABs. And then b times b is b squared. If you can remember that's the pattern for it, then on this over here, you can just take what's your a value, and you can square it. You can take what your b value is and square it. And then in the middle, you just take 2 times their product. Because a times b, well, 2x times negative 3 is negative 6x, times 2 would be a negative 12x. Remember, ask questions in class if this gets confusing, but watch this pattern and practice a little bit. I think you'll be able to be successful. On this one, the only difference is you'll still have the a squared. Let's let you see what the problem looks like. A negative b and a negative b, you'd still have the b squared. The only difference is in the middle you have a negative 2ab. So that's the only difference between those two kinds of problems. Oh, I'm sorry. I gave you that as an example for that one, and this is actually the example for that one. Okay? You do it the same way again. 4x squared would be 16x squared. 2 squared is 4. It's a positive. And now you go 2 times their product. So 4x times 2 is 8x times 2, 16x. It's a little bit faster. In your last unit in this class, you really need to be able to be fast with products and with factors. So that kind of helps you. The other thing I should mention is when you do start factoring, if you notice a perfect square, I'm sorry, I made a mistake on that one. 2x squared should be a 4x squared. Whew! Okay, so if you go to factor this, you would see the first term is a perfect square. Last term is a perfect square. Think about what those would be, 2 and 3. Take 2 times 3, that's 6, and double it, that's 12. You know that that's a perfect trinomial square. And you can go right down to your factor. We'll practice that a little bit in factoring too. So now here's one other kind of special situation. If you end up with a minus b times a perfect trinomial square of a squared plus ab plus b squared, actually that's not perfect because it doesn't have the 2 in there, but it's a similar pattern. If you multiply that, watch what happens. You get an a cubed, this wipes out with that, and this one wipes out with that one, and you get a cubed minus b cubed. So I encourage you to write this down, this pattern in your notes, because when you get this situation you're factoring, it may be easiest to look at this pattern to see how to factor that. Okay? Give you an example. If I had, let's say, x cubed, that's a perfect cube, minus 8. Well, we know 8 is a perfect cube, so we'd go x cubed minus 2 cubed. Now, you could work it out to try to factor it and divide and stuff, things that you'll learn in the future here, but you could also look at this pattern and say, a minus b, well, I see that my a and my b are x minus 2, so I'd go x minus 2. Then I would say my first term squared would be x squared. My last term squared is 2 squared, that's 4. And in the middle I just have a times b. Negative 2 times x would be 2x. Now I don't put the negative in there, I leave it as a positive because I have to be able to cancel out those terms. So that's how it works. Okay? Here's another one. Now look at the difference between those rules. Or what we're doing is a plus b this time instead of a minus b. We've just moved the minus over here. What's cool is this front one matches the perfect cube. Okay? Now the perfect cube has a minus in it, and so does the front one. This time we have a plus there, and watch what happens. These wipe out, and we end up with, we end up with a cubed plus b cubed. And it matches that one there. So that should get you going on special products, multiplying, and factoring a little bit.